Hello, everyone. Welcome to our lab today. This is the determination of the Ksp of a slightly soluble compound experiment. Okay, but before we move uh, to talk about the goal, the purpose of this lab, let me remind you one more time about the procedure, safety procedure of this lab. Okay, before you start this lab, you have to make sure you have your lab coats on. You have your safety goggle. Okay, have your safety goggle also on, and shoes completely covering your toe. Okay, and you have to make sure you have those on during the whole lab procedure. Okay, so what is the purpose of this lab? In this lab, you're going to do a simple acid-base titration of a saturated sodium, calcium, okay, solution of calcium hydroxide. Okay, we are going to titrate the solution with hydrochloric acid. Okay, we're using the hydrochloric acid to titrate the calcium hydroxide solution, and a simple acid-base titration process. And the results of this titration will be used to determine the molar solubility and the Ksp of calcium hydroxide. The procedure of this lab has two parts. Okay, in part one is the preparation of the burette. Okay, part one is the preparation of the burette, and the part two is the titration itself. But before you do the titration, you also have to uh, get the calcium hydroxide, okay, and get the calcium hydroxide ready, and before you start the titration process. Now, to do this lab, you need a solution, saturated solution of CaOH2. You also need 0.05 molar of hydrochloric acid. You need phenolphtaleine. This is a color indicator, okay? And the role of the phenolphtaleine is to actually get you to know when you get to the equivalence, okay? It will give you a color change when you get to equivalence. Also, you need 400 milliliter Becker, okay? 400 milliliter Becker. You do not necessarily need it don't have to be the 400 milliliter. Okay, you can also use 250 milliliter. Okay, to do this titration. Okay, you also need 50 milliliter graduated cylinder. Okay, 50 milliliter graduated cylinder. Now let's proceed to part one of this experiment, of this procedure, the procedure of this experiment. As you can see, I already have my setup here. Okay, so you need to have the same setup at your desk when you come to the lab. Okay, this is the setup. You have the burette. Okay, you have the stand, the clamp. Okay, it's your burette. Okay, make sure you have all those in place before you start the lab. Now, preparation of the burette. You know, I'm gonna use HCl. Okay, to titrate the CaOH2 solution. So I have to make sure I fill up the burette. Okay, you need to fill up the burette with 50 milliliter of HCl. Now, before even I start this video, I already done this part. Okay, I have my burette filled to 0. Okay, now one thing I want to make sure you get, one thing I want to make sure you get before we even move to the second part is that you have to make sure that your burette is clean. Okay, make sure your burette is clean. So in order to do that, you fill your burette to 50 milliliter, fill it to 0. Okay, and then you drain it out. I have done this process also before to start this video. Okay, you fill it with HCl and then you drain it out. That's how you clean your burette. And after your burette is clean, okay, you can fill it up with a new solution of HCl. This is what we have in place now for the titration. Okay, now the burette is ready. We're gonna move to part 2 of the titration. But before you do that, you know you need the CaOH2 solution. You're going to titrate that solution with the HCl. So you have to prepare the CaOH2 solution also. To do that, I already have those my 3 beaker here. Okay, I'm going to fill the 3 beaker with 20 milliliter of CaOH2. Okay, so I have my graduated cylinder. Okay, you should have your graduated cylinder. And I use to measure the CaOH2. Okay, this is what I'm going to do now. Okay, always read. Okay, look at the manuscript. Have the 20 milliliter. I need to get 20 milliliter. Okay, I'm going to pour because I'm used to do this. I'm going to pour the solution, okay, into the graduated cylinder, okay, and get it to 20 milliliter. But if you are not used to this process, you might want to use a pipette. Okay, you might want to use a pipette to do this. So have my 20 milliliter, okay. Gonna pour it into my first beaker, okay. Get another 20 milliliter. Okay, gonna pour it into my second beaker. Right. Okay. Yeah, I'm gonna pour it to my third beaker. Okay. Now I have my 3 beaker filled with 20 milliliter of CaOH2. Let me move those solution to the side so you can clearly see what is happening here. Now, after You fill the beaker with 20 milliliter of CaOH2. You have to add the color indicator, okay? Need 5 drops to each solution. Let me lift it up to show you what will happen, okay? Okay. I have my color indicator. Okay, look at the solution. It's clear at the beginning, but as soon as I add the drop, the color of the CaOH2 change to pink. Okay, what is the reason? You know, phenolphtaleine will get you a pink color when you are in a basic solution. Basic solution, you get a pink color when you add a phenolphtaleine, okay, to a base. That's what you get. Okay, I'm gonna do the same thing, okay, for the other two. Okay, add 5 drops to each beaker. So this is what we have, 3 beaker. Okay, now I'm going to proceed to the titration part. Okay, you're going to titrate, or we are going to titrate each solution, okay, with HCl. And what will happen is that after adding, okay, the HCl to the solution, okay, by increments of 1 milliliter, okay, the color of this solution will change to clear when you get to the equivalence. When you get to equivalence, the color will change to clear, okay? It means that all the ion, the OH minus ion has been cancelled by the H plus ion coming from the hydrochloric acid, okay, solution. Okay, this is what we are going to do. So we start now by increments of 1. Okay, anytime you add 1 milliliter, make sure you shield the solution, the COH2. Okay. Okay. It's going down. Okay, so we get to equivalence. The color of the solution change to clear. Okay, so when you get to the equivalence for the first CaOH2 solution, you have to read the volume of HCl you use for that titration. Mine is showing 15 milliliter. Okay, so you should have your notebook on the side. Okay, we start for V 0 milliliter to VHCl 0 to V, volume of HCl 15 milliliter. So 15 milliliter minus 0 milliliter is equal to 15 milliliter. It means that I use a volume of HCl equal to 15 milliliter, okay, to titrate the CaOH2 solution. Okay, use a volume of 50 milliliter at equivalence point. Okay, so when you get this first volume, you're gonna move to the second CaOH2 solution. Okay, do the same thing. And then when you are adding the HCl, make sure you are sharing the solution in the beaker and to watch out for the clear solution to appear. As soon as the solution change clear, you stop the titration. Okay, you stop it, the HCl. Okay, so this is what we got. This is what we get. I'm gonna proceed to the reading now. Now, for the second titration, I move from VHCl 15 milliliter to volume of HCl, volume of HCl of 29. 29 milliliter. Okay, so 29 milliliter minus 15 milliliter is equal to 14 milliliter. Okay, that's the second volume of HCl I use for the second beaker. Okay, solution of CaOH2 in the second beaker. Now I'm gonna move to the third beaker. Okay, so this third beaker. Always watch out for the clear solution. Good, we get it. Get to the equivalence. Change in the color of the solution. Okay, so soon as we get that, I'm gonna proceed again to the reading, the volume. So at this time we move from VHCl, the volume of HCl of 29 milliliter to the final volume of HCl equal to 43.5. Now, if we do 43.5 minus 29 milliliter, so you're gonna have gonna find 5 minus 0.5, 13 minus 9 is 4. And okay, so I have here 14.5 milliliter. Okay, so that's my third volume. First volume of HCl I use is 15 milliliter. Second volume of HCl 14 milliliter, and third volume of HCl is 14.5 milliliter. Okay, and at the end of the titration, I'm gonna you have to add the 3 volume you get. Okay, this is a titration. You're gonna proceed. You're gonna do the same thing when you come to lab for this titration process. Probably you might have a volume slightly different from the one I'm getting. Okay, depending on how accurate each one is in this lab. You don't have to question. Okay, you shouldn't be too far from the volume I'm getting. You don't have to question your answer. If you are not too far, you should be good. Okay, to go. You add the 3 volume of HCl, and then you divide your answer by 3. It will give you the average of HCl, volume of HCl you use to titrate each solution. With the calculation of that average, okay, you can actually go back, okay, and use the stoichiometry and the dilution law, okay, to calculate the molar solubility. And from there, you can also calculate the solubility product, Ksp of calcium hydroxide. Okay, so then you're done for this titration process. You are the end of the procedure of this lab. So now when you're done, okay, when you're done, you have to clean up. Okay, make sure your desk is clean. Clean up. Clean up here mean dump. You have to drain the rest of the HCl out of the burette. Okay, you drain the rest of the HCl out of the burette, and then you dispose this inside the liquid waste. Okay, so you do the same thing for the three solution. Same thing for the three solution. You dump them in the liquid waste. Okay, and you clean up your desk. So I just drained out my HCl. Next thing to do is to get the burette, okay, fill it up with water, okay, and drain the water out. That's the easiest way to actually clean your burette. So when you're done cleaning up, okay, you then done with the lab.